Under the Geneva's cloak, inside the on the surface of the Earth, is a human marvel, resourcefulness and potential. A sign of impending doom for the entire Hadron Collider, LHC, this machine is an uncommon device for researchers, empowering them to study subatomic particles and uncover the secret of the God particle, the Higgs boson. Famous physicist Brian Cox has made a chilling declaration that has blended miracle throughout the religious community, proposing that something significant has been discovered at CERN with repercussions that go beyond our current comprehension. Before delving into the ramifications of Cox's assertion, it is fundamental to understand how the Large Hadron Collider works. By CERN, the LHC is a 17M ring of superconducting magnets and the most powerful particle accelerator in the universe. It is the pinnacle of human achievement, capable of replicating the circumstances of the universe's creation. This titanic design allows us to discover the mysteries of the universe, realizing something new and potentially disturbing. CERN, established in 1954, is one of the world's most famous institutions of higher learning, with 23 member states and an immense range of member states. The LHC is the focal point for specialists, but it is only one piece of a broad network of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to the speed of light to recreate the universe's energy at the time of the Big Bang. The subsequent impacts multiply the temperature by millions, making it hotter than the sun's core, with a complex arrangement of magnets directing the protons on their journey, while modern cooling techniques keep the LHC at temperatures that are below space. The LHC's design is an engineering marvel, working deep underground and shielded from the rays of cosmic radiation. The entire ring is cooled to a temperature below the vacuum of space, which is crucial for the superconducting magnets to function. There are collisions at 4 points along the corresponding accelerator rings to any one of the 4 principal particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors record the effects of collisions that enable researchers to sort through the debris in search of the elusive Higgs boson, a particle key to our comprehension of the universe's structure. Not only is the LHC an instrument of science, but also a proof of human creativity and aspiration. It represents our quest for knowledge and our eagerness to comprehend the fundamental forces that are shaping our universe. However, as we push the boundaries of our understanding, we must also consider the moral and existential questions. What are the risks associated with exploring the unknown? Could our quest for dominance accidentally set forces free beyond our control? Within the hallowed halls of CERN, the frontiers of human knowledge are constantly growing. A revelation has emerged that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former respected figure and CERN researcher in the field of particle physics, made a recent remark that has both astonished and frightened the scientific community. The goal of CERN's Large Hadron Collider is to recreate a miniature version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential outcomes of this goal, noting the LHC's remarkable ability to create new phenomena, including the possibility that it could reveal the Higgs boson and study dark matter, a substance that makes up a significant portion of the universe. The possibility of recreating a mini Big Bang is not just a theoretical concept, it is a tangible reality within the LHC. The conditions within the collider are analogous to those that existed at the universe's inception, allowing scientists to observe the birth of existence itself. However, with such power comes great risk, responsibility, and accountability. Consider the scenario where something goes disastrously wrong. In 1978, Russian physicist Anat Boryk experienced an accident at the Institute for High-Energy Physics in Russia, where a malfunction caused his head to intersect with a proton beam, resulting in severe injuries. Despite this, Boryk survived and continued his work, highlighting the immense power and dangers posed by particle accelerators. The dangers that a particle accelerator like the LHC poses are not to be trifled with. The potential for unforeseen reactions and the manipulation of the very fabric of spacetime are concerns that are real and expressed by some in the scientific community. One of the most significant fears surrounding the LHC's experiments is the possibility of producing tiny black holes, regions of spacetime with such strong gravitational pull that light cannot escape. If the LHC were to produce even on a small scale, such an entity might potentially consume the Earth. Nonetheless, CERN scientists have assured the public that any black holes created would evaporate almost immediately. Understanding the LHC's operation that could produce a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at speeds close to light, the energy is so intense that it could warp the fabric of spacetime itself. Imagine a trampoline stretched tight with a heavy weight dropped onto it. The surface would warp, and if the weight were sufficient, this analogy might become void, illustrating the potential of the LHC to create a gravitational anomaly. This fascinating but concerning possibility has even caught the attention of prominent physicists like the late Stephen Hawking. In his writings, Hawking warned that, at some point, the Higgs boson may become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a vast event that could destroy the universe. Renowned cosmologist Sir Martin Rees has also expressed concerns about particle accelerator experiments, including those at CERN. In his book Our Final Century, he revisits the potential risks of particle collider experiments, including the formation of vacuum instability. This instability could conceivably initiate a phase transition that would ripple through spacetime, causing a catastrophe of extraordinary proportions. While these scenarios remain highly speculative, even the slightest possibility requires serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The experts at CERN have carefully evaluated the potential risks associated with their experiments and put a lot of safety measures in place, safeguards and protocols to reduce any potential dangers. However, scientific exploration necessitates a certain level of uncertainty. Especially when venturing into uncharted territories of knowledge, the search has always been accompanied by dangers, but precisely this willingness to push boundaries has fueled human progress. The discovery of the Higgs boson confirmed the existence of the Higgs field, which is invisible and provides mass to other particles. This breakthrough was a monumental achievement for the scientific community, offering deeper insights into how fundamental particles acquire mass and helping to complete the standard model of particle physics. However, as groundbreaking as this discovery was, it also raised new questions about the nature of the universe, the forces at play, and the limits of human understanding. While the LHC continues to make strides in unraveling the mysteries of particle physics, it also serves as a reminder of the vastness of the unknown. Each discovery opens the door to new possibilities, new realms of inquiry, and new challenges. The questions surrounding dark matter, dark energy, and the true nature of spacetime remain at the forefront of scientific research, and the LHC is poised to provide further answers. Yet, the pursuit of these answers comes with great responsibility. As scientists push the boundaries of human knowledge, they must remain aware of the potential consequences of their experiments. The LHC is not just a tool for exploring the smallest scales of the universe, it is a symbol of humanity's unyielding curiosity and its desire to understand the very fabric of existence. But this quest for knowledge must be tempered with caution, as the power to manipulate the fundamental forces of nature comes with inherent risks. The scientists at CERN are constantly evaluating these risks and implementing measures to ensure that their work is conducted safely and responsibly. Nevertheless, the potential for unforeseen consequences, such as the creation of microscopic black holes or the destabilization of spacetime, looms as a reminder of the unpredictable nature of scientific exploration. As the LHC continues to operate, it will undoubtedly remain a focal point of debate and discussion. Some will praise it as one of humanity's greatest achievements, while others will raise concerns about the ethical implications and the possible dangers of pushing the limits of science. The search for knowledge is an essential part of what makes us human, but it is crucial that we approach this search with humility, respect, and a deep understanding of the risks involved. In the end, the LHC stands as both a triumph and a cautionary tale. It is a triumph of human ingenuity, collaboration, and perseverance, enabling us to peer into the deepest corners of the universe. But it is also a reminder of the fragility of our understanding and the potential dangers of exploring the unknown. As we continue to probe the mysteries of the cosmos, we must remain vigilant, ensuring that our quest for knowledge does not come at the cost of our safety or the well-being of our planet. The future of particle physics and our understanding of the universe depends on the careful and thoughtful application of the discoveries made at the LHC. It is a tool that has the potential to transform our understanding of the world around us, but it also carries with it a responsibility to act with caution and foresight. The questions raised by the LHC are not only scientific in nature but also philosophical and ethical, inviting us to consider the deeper implications of our pursuit of knowledge and the power that comes with it. As the LHC continues to operate and reveal its secrets, we are reminded that science is not just a collection of facts and equations, it is a dynamic process of discovery, uncertainty, and wonder. The journey to understand the universe is far from over, and with each new discovery, we come closer to answering the fundamental questions that have intrigued humanity for millennia. But with this knowledge comes the need for responsibility to ensure that our search for truth does not lead us into realms we are not prepared to navigate. The Large Hadron Collider is not just a machine, it is a symbol of our shared curiosity, our drive to understand the unknown, and the complex relationship between knowledge and power. It serves as a testament to the heights we can reach when we come together as a global community in pursuit of discovery, but it also serves as a cautionary tale, reminding us that the path of scientific exploration is fraught with uncertainty, risks, and ethical dilemmas. As we continue to explore the deepest questions of existence, we must remember that the pursuit of knowledge is not just about what we can achieve, but about how we choose to wield the power that comes with it. This will be the legacy of the LHC, a legacy of discovery, caution, and the unyielding quest to understand the universe. It challenges us to look beyond the stars, but also to consider the implications of what we might find and how we choose to use that knowledge in the future. The LHC's journey is just beginning, and as we continue to explore the deepest mysteries of the cosmos, it will remain a symbol of the ever-present tension between curiosity and responsibility, between the thirst for knowledge and the need for caution. Discovery was a monumental achievement, validating decades of theoretical work and expanding our knowledge of the universe's underlying structure. However, as with all significant scientific endeavors, the pursuit of knowledge at the LHC has potential, but not all of it. There are energy-related dangers and ethical dilemmas involved in collisions between particles at the LHC. The potential of the LHC is enormous, creating new forms of matter or triggering unforeseen reactions, which cannot be completely ignored. Some researchers have speculated about scenarios in which high-energy collisions could produce miniature black holes or other exotic substances that raise questions about the possible outcomes of such events. The majority of scientists, however, take these risks as being extremely far away. The nature of scientific inquiry necessitates venturing into the unknown. Brian Cox's assertion, highlighting the possibility of replicating a miniature Big Bang in the LHC, underscores the profound significance and potential dangers of this research. The Large Hadron Collider represents the pinnacle of modern scientific endeavors. However, its remarkable capabilities also spark a critical discussion of the restrictions and scientific responsibilities of exploration. The goal of both design and operation is to answer fundamental questions about the universe, yet it operates at the frontier of human knowledge and technological capability. This intersection raises important questions about the nature of science and the ethical ramifications of risk. One of the most exciting aspects of the LHC is its ability to precisely recreate the conditions minutes after the Big Bang, providing a fascinating look at the beginning of the universe. This simulation allows scientists to study particles that existed in the primordial universe and examine the phenomena that would otherwise be inaccessible. By replicating these extreme circumstances, researchers are able to test hypotheses and fine-tune models of particle physics. For example, experiments at the LHC have the potential to investigate the characteristics of hypothetical dark matter particles, which are thought to constitute a significant portion of the mass of the universe, but remain hidden from conventional methods. The quest to understand dark matter is driven by its profound implications for our current understanding of the universe, which remains hazy. Dark matter is inferred from its effects of gravitation on matter that can be seen, but direct detection remains elusive. This is the focus of the LHC's experiments, attempting to produce dark matter particles in the laboratory. If successful, this could revolutionize our understanding of the universe and could result in brand new discoveries and insights that emerge from such breakthroughs. The function of the LHC as a scientific instrument and a driving force for transformative discoveries could alter our perspective in another way. The intriguing area of research is the study of the strong force, one of the four fundamental natural forces. The strong force binds protons and neutrons within the nucleus of an atom, and understanding its behavior at high energies can provide insights into the fundamental structure of matter. The LHC's ability to probe the strong force at unprecedented scales allows researchers to investigate the relationships between gluons and quarks, the fundamental particles that mediate the strong force. These investigations could lead to a greater comprehension of nuclear physics and the forces that govern the behavior of atomic nuclei. Advancements driven by the LHC also have far-reaching implications beyond particle physics. The collider's complex systems for detecting and analyzing couplings of particles have sparked innovations in computer science and technology for sensors, such as the growth of the Internet worldwide. Originally designed as a means for researchers to share particle data, today's physics experiments at CERN have changed the world. Information dissemination and communication advancements in computing and data management required for the LHC have had a cascading effect in a variety of fields, illustrating how major scientific research can drive technological advancement. However, the operation of such a powerful instrument also requires strict safety regulations and moral considerations. The potential for unexpected results, such as the creation of new or exotic particles, necessitates a careful assessment of risks. While theoretical models suggest that the likelihood of catastrophic events is very low, the possibility cannot be entirely ruled out. This uncertainty demands that researchers approach their work with caution and openness to ensure that safety protocols are effective and that the public is informed about potential risks and the measures taken to lessen their impact. Public engagement and understanding are crucial components of scientific research, especially for projects with the potential to impact society at large. The LHC has generated significant interest and discussion, underscoring the importance of communicating complex scientific ideas. A science communication strategy that works for the audience helps simplify research and encourages informed public discussion of the implications and risks associated with advanced scientific experiments. By maintaining an open dialogue with the public, scientists can address concerns, dispel misconceptions, and build trust in the scientific process. As we move forward, the continued operation of the LHC and the potential for new discoveries raise important questions concerning the future of science. The Collider's ability to probe uncharted territories of particle physics may raise new concerns and challenges, pushing the boundaries of our knowledge even further. The pursuit of these frontiers will require ongoing collaboration among scientists, engineers, and policymakers to ensure that research is carried out in an ethical manner and that the benefits of scientific progress are maximized while minimizing potential risks. The LHC serves as an example of creativity in human engineering and the insatiable thirst for knowledge. It represents a convergence of cutting-edge technology, theoretical physics, and international cooperation that exemplifies the collective effort to understand the universe's deepest secrets. As we advance in our exploration of the fundamental forces and elements that form our world, it is essential to remain vigilant about the implications for ethics and the potential consequences of our research. Bringing the Large Hadron Collider to an end remains at the forefront of scientific inquiry, offering unprecedented insights into the universe's nature. Its experiments have the potential to open new realms of knowledge, drive technological advancements, and reshape our comprehension of existence. But with its extraordinary capabilities come important responsibilities. The goal of knowledge must be balanced with a dedication to safety, openness, and public engagement. As researchers continue to explore the frontiers of particle physics, the LHC will remain a demonstration of human curiosity and the quest to unravel the fundamental mysteries of existence. As the Large Hadron Collider, LHC, continues to operate at the cutting edge of scientific discovery, it challenges us not only in terms of our understanding of the universe, but also in how we balance progress with responsibility. The ethical considerations involved in conducting high-energy particle collisions, and the potential for unintended consequences, remain a central issue. Though the risk of catastrophic events is statistically low, the very possibility of creating new forms of matter, including potentially dangerous particles, demands that we remain cautious and vigilant in our approach to these groundbreaking experiments. Moreover, the LHC's impact goes beyond just particle physics. It acts as a catalyst for innovation across multiple fields, pushing the boundaries of technology and engineering. For instance, the development of detectors, superconducting magnets, and the sophisticated computational tools required for data analysis has led to advances in areas such as medical imaging, data storage, and telecommunications. In many ways, the LHC is a testament to the interconnectedness of scientific fields and the way breakthroughs in one area can spill over into others, benefiting society at large. However, there is a pressing need to ensure that the fruits of such research are shared equitably. As the capabilities of the LHC expand, so too does its potential to spark debates around the fairness and accessibility of scientific advancements. Global cooperation and transparency in the use of such technologies are essential to preventing monopolies or unequal access to knowledge and resources. The LHC is also a focal point for international collaboration, bringing together scientists, engineers, and researchers from all over the world. This global effort highlights the power of collective action in solving some of the most profound questions of human existence. Yet, as science advances, it becomes increasingly important to involve the public in these discussions. Scientific literacy and engagement will be key in navigating the ethical challenges that lie ahead. Public understanding of the risks and rewards associated with such pioneering research will play a pivotal role in shaping policies that govern the future of scientific exploration. In the years to come, as the LHC continues to probe deeper into the fabric of the universe, it will undoubtedly lead to new and unexpected discoveries. Some of these findings could transform our understanding of fundamental physics, perhaps offering solutions to long-standing mysteries like dark matter, dark energy, and the unification of the fundamental forces. Others might spark entirely new areas of inquiry, revolutionizing our understanding of the cosmos. However, Each step forward in this journey must be taken with a sense of humility and responsibility. While scientific exploration holds immense potential for progress, it also carries risks that cannot be ignored. The LHC, as an emblem of human curiosity, stands as a reminder that progress in science is not just about seeking knowledge, but about doing so in a way that respects the broader ethical implications for humanity and the world we inhabit. In conclusion, the LHC is more than just a tool for scientific discovery, it is a symbol of human aspiration, collaboration, and the relentless pursuit of understanding. Its journey will continue to shape the future of science and technology, but it also reminds us of the importance of wisdom, caution, and responsibility as we push the boundaries of what is known and what is possible. The pursuit of knowledge should always be tempered by a commitment to the welfare of all, ensuring that the advancements we make are used to enhance, rather than harm, the world we share.